And the warm-up here is to solve for y prime in terms of y and x, because what we're going to be doing is we're going to be taking the derivative of both sides of the equation. It's called implicit differentiation. You know, before we just had like y equals x and we took the derivative of the right. That's all we did, isn't it? We just wrote y prime on the left or something like that. Well, the stuff we do today is not so simple. We won't have just a singular y on one side. It'll be something with a power. So we actually have to take the derivative of both sides. And that's called implicit differentiation. Now, one of the things you have to do, though, is you have to be able to solve for y prime or dy dx, however you're doing it. So that's kind of warm-up. Solve for y prime. So somebody has already done all the calculus on this and taken the derivative of the left and the right. And your task is to solve for y prime. Don't overthink that. Just go through basic isolation steps. What's something you could do to isolate y prime? Yeah, you could add 2x y the other side. Good move to me. So you have x squared y prime equal to 4x minus y plus 2xy. And none of those terms are alike, are they? So don't bother putting them together. That wouldn't make any sense. What's the last thing you have to do to solve for y prime? Divide by x squared. It's done. Y prime is all of that over x squared. You could probably divide each of the three pieces and make it look a little bit different, but that's the gist of it. Let's see, that one's got a little trig in it. This one's actually interesting because there's a y prime on both sides. That makes it a little bit harder to do. So we'll do that one. I probably don't have room up there for that. Now, does anybody have any idea where to start on 7? When you were in 8th grade, when they first started throwing these x's at you, we had some pieces with x's and you had some numbers. What did you do with all the x's? Put them on one side. Put everything else on you. What's wrong with that? Do the same thing you did in 8th grade. Put everything with y prime on one side and everything else. They taught you all the stuff you needed for this. So I already see that y prime sine of x is where it needs to be. I'm just going to leave it on the left. Anything else you want to move in? No, move that guy. Subtract x y prime. And all the other crap, where's it go? Other side. There's already a y on the other side. And we're going to add to it x cosines of x. That's the first thing. Just go back to 8th grade. Yes, commandment 1. What can you pull? What do both pieces on the left-hand side possess? Y prime. So you pull that y prime. You pull it from y prime sine of x, what's left? Sine of x minus, because there's a minus, minus x. That's a good line too. Now you're ready for line 3, the last line. Divide, that's right, rather. So y prime is y plus cosine of x, sitting over sine of x minus an x.
Don't you still have the x in front of the cosine?
Did I drop it? I did. Didn't mean to. Was that so bad? That's probably the hardest part about today, to be honest with you. It really is probably the hardest part about today. Is the final isolation step. So if you can handle that, if you think you're okay on that, you'll probably be in pretty good shape today. Now, we got the basic steps here written out, I think, on the next slide, maybe. or implicit differentiation. So you differentiate both sides of the equation with respect to x. Now I won't be using the y prime notation for this, because when I take the derivative of something that's not x, I'm literally going to say dy dx. Every time I do something that's not x, I'm going to say dy dx. Okay? That's saying I took its derivative with respect to x. That's all it's saying. And we already did kind of steps 2 and 3 and 4 when we did that prereq stuff, didn't we? Everything with a dy dx on one side, that was y prime. Factored it out. We did that. Solved for it. So you guys already know how to do steps 2, 3, and 4. It's just the first step that you don't know how to do. And it's a really easy step. So here's our first one. Find dy dx if y cubed is x. Now, imagine y cubed was x cubed. What would you do with the x one? Bring it out front, wouldn't you? And then what would you do with it? If you bring that exponent out front, you have 3 y's. What column? Second. Now, you're not taking the derivative of x here. So this is where you introduce dy dx. You're saying I took the derivative of y with respect to x. So you just got to include the dy dx piece. That's really all there is to it in this differentiation. Knowing that dy dx, you took the derivative of something that wasn't x. Say you did. Now, what's the derivative of x?
1.
Yeah, it's 1. I don't know why I was going to write x now for some reason. It's just 1. There's no reason to say dy dx here. Because it was x, wasn't y. I'm going to go back and double check myself and make sure I'm doing that right. Just in a minute. But that's what I remember doing. Anytime you make dy dx is if it's not x. But I've been wrong in the past. Alright, so it's more or less done. Dy dx is on one side, we just need to perform the isolation step. So what do you divide by? Over squared. This is the derivative of y with respect to x. It is 1 over dy squared. Anybody got any issues with that? Sure. All right. So here's another one. Find dy dx if 3y squared plus twice y is 5x. So you actually have two things on the left with y's that you're going to differentiate. What's the derivative of 3y squared? 6y, and it wasn't x. Dy dx. Derivative twice y. Do what? Dy dx. Derivative 5x? 5. Now, if you look at that little 4-step thing over there, we don't have to do step 2. We just have to do step 3. What do both these on the left-hand side contain? So pull it. And I am a bigger fan of dy dx than prime notation. Just because it says what you're doing. You guys agree with 6y plus 2 being left over? Now, these derivatives do look funny because they still usually contain a y. That's what makes it look kind of funny. All right, so all you gotta do is divide by 6y plus 2 and this thing is done. What is the derivative of y with respect to x? Any issues with that? I was going to look through your book real quick and see if we have better examples we'll use. We do have an example too, but it's not going to mean much to you. It's about lenses. It's pretty big deal if you wear glasses. There's really not anything in here that's directly applicable. just from the project, you guys kind of realize that before you really start doing anything with math, it's got to be pretty higher level, doesn't it? Like even just drawing shapes, that took knowledge of some fairly complex shapes in math. That was just a drawing. And the reality is, to really start applying math, you've got to know a lot of math. But we don't have too much in this book because you just don't know a whole lot yet. Now here's an easy example. Find the slope of a circle, x minus 3 squared plus y plus 4 squared equals 36 when x is 6. Yeah. How do we find slope? How do we find the slope at any x value? How do you do it? What do you take? Take the derivative. That's all you do. You take the derivative. Now there are two ways you could approach this. You could FOIL out x minus 3 squared and y plus 4 squared. Then take the derivative. Or you could apply a rule that you learned in 3-6. What's the big deal about 3-6? Chain rule. Apply the chain rule, or the outside-inside rule, however you want to think about it. Yeah, I'll leave it up to y'all. We'll do it however you want to do it. Oh, you're going to take the long route on me. Okay. It is a little bit longer. It's longer mainly because of the isolation that has to be done. But you're still young. You don't know any better, right? So x minus 3 times x minus 3. You got it in your head? Y plus 4 squared. That really wasn't that long. It really wasn't. So now we're going to take a derivative of everything we see. Not just x's. Every single thing you see, take a derivative. And when you see a y, what do you add? You just add the y to the x. Now we won't do it. So derivative of x squared is 2x. I have a different color for those of you at home. Derivative of negative 6x is. What's that derivative of 9? 0. Plus derivative of y squared. 2y dy dx. Derivative of 8y. 8 dy dx. Derivative of 16. Derivative of 36. This one wasn't too bad even that way. It really wasn't. Wow.
If we understood this one this way, because it's the steps, but so we couldn't name the lines already before we got to them.
Yeah. I know we can do it. That's a pretty good idea. Our idea was to, just in the start, since you know you're doing implicit, put all the y's on one side and everything else on the other. Would that have been fine? I hope so. It said that I was recording.
I didn't know like if you're not playing laptop, still be technical.
You know, I don't actually know that, but I know if I sit down, I have like this triple chin thing going.
It's not as bad. It's possible, but
I'm pretty sure there is volume. Can you hear me? It says there's volume. Well, we'll find out, won't we? If I step away, can you still hear me? Yeah, it's still moving. There's volume. Anyways, where were we? Oh yeah, dy is on one side, everything else on the other. 2y and 8, I kind of feel like being a little lazy here and saving a lot of text. Can I just go ahead and pull dy dx from 2y and 8? dy dx, parentheses 2y plus 8. And the rest of that stuff goes on the other side, so the sign changes. And you're basically done with this problem, except for the actual application issue going on here. What are we going to divide everything by? 2y plus 8. There's your derivative. Negative twice x plus 6 over 2y plus 8. Now, don't turn the page and move on the next slide because you're not done. Your goal was to find the slope of this circle at x equals 6. Now, that's an equation that'll give you slope, but it doesn't just have a variable x in it, does it? It also has what variable? Y. So you're not done. I didn't give you a y point. Thankfully, it's not that hard to find a y. It's really not. Shrink this up and move it around here. So this little guy right here, it needs an x and a y. How on earth could I get a y? Plug in x, yeah. I know x is 6. It's given to me. So 6 minus a 3 to the second plus y plus a 4 to the second. Don't be surprised if you get two y values back. Must be 36. I just plug it in. 6 minus 3 would be 3. 3 squared would be 9. 36 minus 9 is what, 25? Did I lose anybody what I did there? I just did some math. 6 minus 3 is not 3. 3 squared is 9. Took away 9 from 36. Now what are you going to do here? Yeah, take the square root of both of them. So y plus 4 is a plus or a minus 5, right? You think it matters which one you use? It might. There's only one way to know for sure. Look at the graph. So I'm going to actually type in the original circles equation on Desmos. I'm not going to spend time with the TI-84 on it, because on TI-84 you have to solve for y, don't you?
Shouldn't that equal 27?
Can I not subtract? 36 minus 9 is 27. Thank you. I cannot subtract. Root 27. X minus 3 squared. Now what are we about to come up with here? We're about to come up with negative 4 plus or minus the root of 27 for our two y values. So about 1.2 and negative 9.2. This is kind of why I wanted to look at the graph. So 1.2 is going to put you about there. Negative 9.2 is going to put you somewhere down there, isn't it? Same slopes or different slopes? Ruh-roh. We don't know. Well, what was x value? 6? I completely drew that in the wrong spot. I was focusing on the y value. When x is 6, y has a value of about 1.2, which is right there, right on the circle, because these are slopes of tangent lines. And we also have a y value of about negative 9.2. Different slopes. You don't have one slope. You have two slopes. Okay. By the way, what kind of line did I draw in? Touched once. Tangent. These are always about slopes of the tangent line. So yeah, there's actually two answers to this thing. There's always two answers. Now the question is should I be using these rounded numbers when I do it? Probably not. You probably should never round to the end. All right, so I'm going to steal this equation right here. Moving on to the next page. You know, it's not so much that math is tedious, it's that showing all the math is tedious. You can do a lot of this stuff in a calculator pretty quick. It's the showing part that makes it tedious. I am going to do the work in a calculator. And let's see here. That x was 6 and y was it negative 4? Negative 4 plus or minus root 27. I'm going to be a little lazy on my TI-84 here. I'm going to take a 6, I'm going to store it to x. Then I'm going to take a negative 4 plus a root 27. And I'm going to store it to y. Get out of that radical first. You actually have the alphanumeric y on your keypad, don't you? Yeah. So you just hit alpha and then y. And then I'm just going to use parentheses and type in the expression. Negative 2x plus 6. Close, divided by parentheses 2y, alpha y plus 8. So there's one of them, about negative 0.58 or so. The other one is probably the same thing, but the sign would be what? Positive. It should be, because circles have pretty good symmetry, but I don't know. I don't really like to make assumptions. So negative 4 minus root of 27y. Root of 27. Still going to store it to y. And then second enter twice, actually 3 times, and I should be able to bring up that equation I typed in. Oh, just twice. Yep, same thing, just positive. So maybe remember that when you do a circle, that you really only have to pick on one number. It's just a plus and minus because of the shape of the circle. It's exciting stuff, isn't it, Elizabeth? Math doesn't really get exciting until you just really see what you can do with it after you know a whole lot of it. It's one of the disclaimers about math. For it to actually be useful, you have to know a tremendous amount of it. Then it becomes useful. Here's an application of this particular section. It deals with lenses. So there is a law that describes how light changes direction as it enters a lens. The most important angle is the angle that light makes. Like literally just think about when you're looking at something. As light enters your eyes straight. Okay, that's the most important angle. I'm pretty sure when you go get glasses, heck, it's been a while since I had my prescription done, but they don't ask you to like look off to the left and try to read the letters, do they? No, straight. That's where your attention is. That's where your focus is. So the most important angle is the angle where light is entering your eye, just straight at it. You guys know that more as the normal curve. By the way, all lenses are quadratics. The ellipse, that's an ellipse. It's got a second degree exponent. That's a quadratic. Your hyperbolas, those are lenses too. They were x squared and some y squared stuff. All lenses are called quadratics. But in order to find these normal slopes, we have to be able to take the derivative of these quadratics. So optics requires knowledge of calculus, specifically implicit differentiation. So here's our goal here. It says find the tangent and normal. Instructions are kind of vague there, but they want you to write the equations. Find the tangent and normal equations. Which actually the ellipse x squared minus xy plus y squared is 7. We're just going to take derivatives. We could get everything on one side if we wanted. It's really up to you. I'm just going to start taking derivatives off. What's the derivative of x squared? 2x. Right, minus xy. Oh, bummer. That's the product of two things. Is xy the product of two things? Because xy is the product of two things. So it's going to take us a minute. We're going to have f of x, sorry. Anyways, I don't know why I call it f of x, I'll call it h of x. Some other function. H of x is this xy piece. I ain't too worried about the negative sign. So f of x is the first piece x, which makes f prime of x what? 1. G of x is the second piece y, which makes g prime of x dy dx. Because you took the derivative of something that was an x. And then you just kick in the product rule. All right, so I have x times 1, which is just x. Is it plus or minus? Minus. Why did I say x times 1? What was x times 1? It was x times 1. dy dx. Minus y times the first function 1. There's a product rule for that piece right there. Then you got to take the derivative of y squared, which is y dy dx equals dy dx. And that is going to have to equal a big fat 0. From there, it's just basic algebra. Move things around. You'll be fine. If you want to do it in one line, that's fine. You want to do it in two lines, that's fine too. I don't care. But I see on the left, I'm going to leave a couple of things on the left. There's a negative x dy dx on the left. And there's also plus this 2y dy dx. I'm moving everything else to the right. So on the right, I'm going to have this guy right here. Negative times negative is positive, becomes negative. Minus y minus 2x. I kind of skipped a line. Well, you all do that, don't you? I know you do because you make mistakes. Probably shouldn't, but you do. You see any mistakes in that line? Because I'm really tired. You good with that line? Max, you good with that line? You know what happened?
Yeah, I know it happened, I can see my.
Huh? I just doing a whole lot of things at once.
Why is that not the, you streaming into that? Is that what? That's not what.
Well, can you hold a lot of conditions like that?
Why not? The only thing in front of it was a negative symbol.
Okay, you just moved it over.
I just moved stuff around. Yeah. I'm just moving stuff around. That's all I'm doing. What do both pieces of the left-hand side have in common? Both have a dy dx. Just do a little factoring. This is the easy part. I swear this is the easy part. If you pull a dy dx, I'm going to change the order here just to make it look prettier. 2y minus x instead of negative x plus 2y. Any issues with that? So I have dy dx times, there's a little gap there. I'm not introducing a multiplier symbol. I got on to you all about that. Times 2y minus x, and it's the isolation stage. Divide out. There's your derivative. And that was the fun part. Actually, this one's pretty easy for the next step part too. You were lucky enough that in the text, what'd they give you? They gave you both points. So your slope is pretty easy to find. Your slope, your dy dx, however you want to call it, is a negative 2 minus twice a negative 1 sitting over twice a 2 minus a negative 1. Is that 0? 0 over 3, isn't it? It's 2. I think it's 0 over 3. It's kind of hard to do when it's written sideways like that. 0 over 3, is that what y'all are getting? Yes, because minus the negative is addition. The top part is negative 2 minus. All right. Now, what slope did you find? Did you find the slope of the tangent or the normal? What's the slope of the tangent? What's the slope of the normal? It's 5 over 0, which is undefined. This is actually a really easy question. But the odds of you remembering are slim, I think. What kind of line has a slope of 0? All right, so I know this is a horizontal line. You got to remember that. It's a horizontal line. passes through negative 1, 2. What's its equation? Don't even do point slope. It's a horizontal line, passes through negative 1, 2. Y equals 2. The normal has an undefined slope. What kind of line is that? It's a vertical line. Passes through negative 1, 2. Yeah, the equation is x equals negative 1. So this one's really easy. You shouldn't do point slope form if your slope is 0. You can, it'll be fine, it'll work its way out. But you cannot do point slope form when you don't have a slope at all. That's why I'm saying these are more conceptual as opposed to a formula. So that was your applied problem, your lenses. And I'll be darned, we actually finished a lesson in a single day. That's right, Elizabeth, that's right. With everybody out already for Rona, I'll probably give you guys 2 days to prep for your test. Tomorrow I'll give you a test review sheet. And we'll give you your test on Thursday. Go ahead.